So very good morning students. Today we are going to discuss about Rankine cycle, which is the ideal cycle for vapor power plant or steam turbine power plant. So as you know, a power plant converts thermal energy in the fuel into mechanical energy and finally to electricity. So first I will draw the schematic diagram of the vapor power plant or steam turbine power plant. So there are four components: the boiler, turbine, steam turbine, condenser, and then a pump. So these are the four components in a steam turbine power plant. So let us see the Rankine cycle, the ideal cycle corresponding to this vapor power plant or steam turbine power plant. So I will show you the TS diagram, temperature entropy diagram. Temperature on the x-axis and entropy, specific entropy on the y-axis. You have the vapor dome here, and you have four different processes taking place in this closed system. So there are two isentropic processes and two constant pressure process. Okay, so isentropic processes are taking place in the pump and the turbine, and constant pressure, heat addition and heat rejection are taking place in the boiler and the condenser. So heat will be added here and heat will be rejected here in the condenser, and there is some work input in the pump and work output in the turbine, and it will be connected to a generator here. Fine. So correspondingly, let us see how the temperature entropy diagram for the ideal Rankine cycle looks like. Okay. Let us name the points 1, 2, 3 and 4. So 1 to 2. 1 to 2 is the heat addition process. 2 to 3, the isentropic expansion. 3 to 4, which is taking place in the condenser, is again a constant pressure process, heat rejection. 4 to 1 is taking place in the pump, where isentropically work will be added and the liquid will be, we can't say liquid will be compressed, but the pressure of the liquid will be increased to the boiler pressure. Now, so 1 to 2 is a constant pressure heat addition. So it will be liquid here, you can see. There are 3 stages in the boiler. So entry will be saturated liquid or compressed liquid. So this point corresponds to the compressed liquid. That is the ideal case. And the exit of the boiler will be the superheated vapor. So liquid will be converted to vapor in the boiler. So phase change happens in the boiler. So then 2 to 3 will be isentropic expansion. Isentropic, entropy remains constant. So is the vertical line in the TS diagram. So you can see that is taking place in the turbine, isentropic turbine. Now after that it will be, so vapor will be entering to the condenser where the heat rejection will be taking place in the condenser. Process 3 to 4, and 4 to 1 again isentropic. The pressure will be added in the fluid with the work input in the pump. So these are the 4 different processes. All are internally reversible. There are no internal irreversibilities present in the Rankine cycle. That is why it is known as the ideal cycle for a vapor power plant. So these are the different processes and the schematic diagram and the TS diagram. I hope it is clear. If you have any doubt, please feel free to ask. Thank you.